Hello, I'm Jason with ScienceAndMath.com. Today we're going to use food coloring, water, and a candle to show how air pressure can actually force water up a column. It's a really simple experiment to do, but actually very impressive. All you'll need for this guy is some very simple things that you'll find from around the house. You'll need a plate, you'll need a candle, and you'll need some food coloring. It doesn't really matter what color food coloring you have, but I chose blue in this case. And then you'll need some water that you can pour, and then you'll need an empty glass. Now you're going to want to make sure that the glass is able to fit around your candle that you actually choose to use, and you'll see why that's important here in a minute. So what we're going to do is just move this guy over here, put the candle in the center, and then what we're going to do is pour some water into this plate. Now, how much water do you need? You really don't need a lot of water, but you want to go ahead and fill it up where you have a fair amount of water, something like this. All right, and then what you want to do is put this candle right inside like this, and of course you want to light the candle, and you want to get your permission from your parents for sure to do this, or an adult, and wear your safety glasses, because anytime we're working with candles or anything like that, we definitely want to be safe. So let's go ahead and light this candle. There we go. Let's let it go ahead and get nice and hot. Basically what's happening here, if you think about it, anytime you light a flame or light a candle, is the flame is starting to grow, and right above this candle is a pocket of air, a whole column of air right above the candle, and this column of air is starting to get hot, okay? So and that's going to be very important for this experiment here. Now the next thing we want to do, while the air is getting hot and while this candle is starting to work itself out, is we want to make this water colorful. The only reason we're doing this is so that we can see the water as it rises up into the glass. So what we're going to do is just put a nice bit of food coloring, probably too much food coloring, but we like food coloring, so that's okay. And just give it a nice gentle stir. Want to be careful not to make a mess here. But want to give a nice gentle stir, okay, so that it's a nice even blue color. So there should be absolutely no way that we would not be able to see this blue water as we do the experiment here. All right, so the next thing we're going to do is take our empty glass, which is the one that we have right here that fits over the candle. We're going to turn it over on top of the candle and push it all the way so that it's sitting inside this water. And I want you to look very, very carefully at the level of the water inside of this glass as this happens, okay? On the count of three. 1, 2, and 3. Now let's watch carefully. So the candle is going, and the candle is using the oxygen inside of this guy here. It's heating up the air, and then eventually, because of the seal there, the oxygen is all being used up. And then what happens here, look what happens here. As the candle goes out, the water level is rising, rising, rising inside of that cup. And you can see the water level rose probably maybe 1.5 centimeters, something like that there. So this is a demonstration, again, in air pressure. I can go ahead and take my safety glasses off now that we've actually done the experiment. What's happening here is whenever we light the candle, we said more than once that it's heating the air up, right? And we already talked about in other experiments, when you heat things up like air, they want to expand, they want to get bigger, right? So the air that's sort of in this pocket around the candle, it's wanting to expand, it's wanting to get bigger, it's wanting to push away, right? And so when we cap off the top of it with the cup, we exhaust the oxygen supply. The candle can't burn anymore because there's no more oxygen inside. So slowly the candle flame goes out. Right? Now, as soon as the candle flame goes out, there's no more heat being produced inside of this guy. So the air that was left behind, you know, the air tried to push its way away from the candle. Whatever air was left behind immediately starts to cool off, right? What happens to gases when they start to cool off? They start to get smaller. They start to contract, right? When things contract, we say they have lower pressure. When things expand, we say they have higher pressure. So what really happened here is we made the air hot so that when we capped it off and cooled off the air that was left behind, it starts to contract, and the pressure inside of this glass gets lower because of that. So what we have at the end of the day, once the candle goes out, is we have low pressure inside of this glass. And where's the other pressure at in this situation? We have higher pressure outside the glass because of the atmosphere. We don't feel that pressure, but it's always there. So we have so much pressure pushing on the water all around this glass. It's pushing down, that's atmospheric pressure. And then inside, we created a situation where we have low pressure. So we have a low pressure inside, which means low pushing, high pressure outside, which means higher pushing. So the outside air pressure pushes the water level down, up into the glass. It goes down around the bottom lip of the glass and goes up. And you can see it with the food coloring. The only reason that we used food coloring was so you could see it. So really you can do this experiment with a candle, a glass, and a plate and some water, and you don't even need the food coloring. That's just to help you, get a little bit of a kick out of seeing it rise. And you can see that it probably went up a good 1.5, almost 2 centimeters, something like that. So go grab an adult, go get the materials, and show yourself the power of air pressure, that it's pushing on us all the time. We create low pressure inside, high pressure outside, and that forces the water level up into the glass.